where is sine equal to 1/2? That's at pi over 6. So 15 of you answered C, pi over 6, which means a bunch of you answered other junk. Make sure it's just a little mistake and you understand what we're doing. All right, our next one says cosecant of pi over 3. Cosecant, are you on the unit circle? Yes. No. Don't worry about it. It was me. It was me. All right, cosecant. It turns out it's not on my unit circle. I accidentally said yes. Cosecant is not on our unit circle, but you will not do the reciprocal inside. There's a couple ways to catch that mistake. The first thing I'll look at is pi over 3 is a nice angle that's on my unit circle. If I flip that to 3 over pi, can anyone find 3 over pi on your unit circle? Not a good sign if you were to flip this. And remember, you never, ever, 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 ever flip the angle. It's always the value. Why we do the reciprocal inside here is because the value is on the inside. Here the value is not on the inside. So instead what we're going to do is we're going to find the sine of pi over 3 and flip it. Algebraically, it looks like this. 1 over sine of pi over 3. But once again, I like to just use my fingy and just find where is pi over 3, find what the sine is, and flip that value. Well, the sine of pi over 3 equals root 3 over 2, which if you flip it becomes 2 over square root of 3. And if you look at the board, that's not on there.
2 root 3 over 3.
So it's going to be 2 root 3 over 3 because we simplify this by multiplying the top and bottom by square root of 3. Equals 2 square root of 3 over 3. The correct answer is B, 2 root 3 over 3. Questions on either one of these two?
That point's going to help now.
Well, you have to miss both of these to lose a point, or half a point. Whenever we do 2 of them, you have to get both of them wrong to lose a point. As long as you got one of them, I'm like, okay. Woo. Okay.
Dodging bullets.
All right, secant inverse of 2. It's basically the same question as the first one. It's just the only difference is secant goes to cosine. I will ask the same question. Secant is not on the unit circle. Inverse inside, the value's 2. It's inside, so we do the reciprocal inside. So I'm asking you, when does cosine equal 1 over 2 this time? Well, cosine equals 1 over 2. I shortchanged you a little bit. What quadrants does cosine inverse exist in?
1 and 2.
These ones, 1 and 2. What quadrants does sine inverse exist in? 1 and 4. Let's talk about that in a second. I'm going to put a pin in that for just a second. I want to go back to that. But we're doing cosine inverse of 1/2. I only have to look at quadrants 1 and 2. And this turns out to be pi over 3. Cosine equals 1/2 at pi over 3. Secant pi over 3. Secant is not a unit circle. I have to do the reciprocal. We don't do the reciprocal inside because you never, ever, 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 ever flip an angle. So that means I'm flipping kind of on the outside. I guess we kind of look at that I find cosine of pi over 3 and flip the value. Well, that would be 2, correct? Because cosine of pi over 3 is 1/2. Flip it, it becomes 2. Algebraically, it looks more like this, which you flip that to be 2 over 1 or 2. I just went the long way around of just, instead of using your finger to figure out 2 over 1, I just actually did the algebra behind it. Questions on the bell work? Okay, then I put a pin in something that we need to know for tomorrow. And that's specifically sine inverse.
So did you have a question on the homework or the bell work?
I haven't asked either yet. Okay, I did want to talk about sine inverse really quick. Sine inverse is going to trip people up because sine inverse exists in quadrants. So if you remember, I said a good idea is to write cosine. If you write cosine, you know what quadrants cosine and sine exist in. If you wanted to, you could have added your secant and your cosecant. But I'm more concerned about sine inverse right now. Sine inverse exists in 1 and 4. In 1 and 4, we have a problem, particularly if I get to quadrant 4. If I would ask you for the sine inverse of negative 1/2, we will still have a bunch of people that tell me it's 11 pi over 6. Why is that incorrect? Even though all my thought process is correct, I find negative 1/2. It points to that angle. Why is 11 pi over 6 incorrect, Jordan?
You can't go to where everything was crossed out.
You cannot go to where everything is crossed out. You can't go past there, so we need to go down. So it's going to be negative pi over 6. I guarantee there'll be at least one of those on the quiz. And there'll be a couple on the test.
Sounds like cosecant too, right? Like you can't go all around, so there's going to be.
Yes.
Okay.
Yep, it works for cosecant as well. Cosecant inverse, same exact thing. All right, that was our quick review, but do we have any questions on the bell work knowing that this is basically our quiz, just with other stuff added to it?
Is there going to be like the complicated ones on the quiz where it's like multiple steps?
Nope. I am just quizzing on you. Do you understand reciprocals and do you understand inverses?
What is the other stuff?
Maybe 20.
So we already have secant, cosecant. We'll have maybe some sine inverses. It could have tangent on it. It could have cotangent on it.
Can we do an example of each of them? Or just the ones we didn't do? Like the tangent one?
Sure. Just ask them from the homework because we just did homework on those. All right, what questions do we have? We have 20?
20, yeah.
20. So we just look at our homework. That'll be a good place for ask me how to do certain problems. 20. 20 says cosecant. Be aware that you need to know how to do these problems. I know there's people still struggling with these. You're just overthinking how to do these. You're looking at the entire thing at once and you're thinking you're going to solve it at once. That's not what these are. These are composite functions that tell you to do the inside first and work your way outside. So the very first thing I would realize is to make my life simple, I'm just going to focus on what's on the inside of this, and that's secant of pi over 3. My goal is to figure out what secant of pi over 3 equals. Well, I'm going to note that secant is not on our unit circle, so I do need to do the reciprocal. We will not do the reciprocal on the inside. Instead, we're going to go to pi over 3, find our cosine value, and flip it, which algebraically looks like this. That's all this is saying. All 1 over cosine of pi over 3 says is find cosine of pi over 3 and flip that fraction. Well, cosine of pi over 3 is 1/2. You flip 1/2, it becomes 2 over 1, which is just 2. So all of a sudden, I have from cosecant inverse of secant pi over 3, it becomes cosecant inverse of 2 over 1, or just 2. Cosecant is not on your unit circle, so we need to change it to sine. By doing the reciprocal inside, inverse reciprocal inside. Remember, that only happens if it's not on the unit circle. I should not see you guys taking reciprocals if it's just sine of something, or cosine, or tangent. The only time you need a reciprocal is if it's not on the unit circle. Well, sine inverse of 1/2 is pi over 6. Does that make sense?
Yeah.
Okay.
How'd you go from 1 over cosine of pi over 3 to 2?
I did some work in the background. I was going through my method of I just find cosine of pi over 3 and flip that fraction.
Okay.
But more algebraically, this would look like 1 over 1/2.
Okay.
Because the cosine of pi over 3 is 1/2. Flip that fraction, becomes 2 over 1, or just 2. Yeah?
Just to clarify, you said you only flip it when it's not on the unit circle?
Not on the unit circle. That's the only time you have to worry about that. So that's why I always start, is it on the unit circle? If not, we need to do reciprocal somewhere. So that's just cosecant, secant, and cotangent. The rest should be just go to unit circle and find that value. Yeah? Sure.
I figured out.
Okay, cool. Yeah. Okay. No homework questions? Okay, sure. Other questions from the homework? I said sure, you can go.
We do.
Yeah. Sure.
Number 13.
I had a question for 8 first, and then we'll do 13. 8 says the cotangent inverse of... so, Maddie, this is a good one because this covers our cotangent one that you said we could possibly show.
Number 8?
Yeah, because it's cotangent inverse of negative square root of 3 over 3. This is the hardest question. This is it. This is the granddaddy of people are going to get this wrong. And that's because cotangent and tangent do not exist in the same quadrants. If you remember, cotangents 1 and 2, and tangent, maybe I should put this in red so you can actually see it. Because we just write cotangent. But let's forget about that for a second. Let's do this one wrong and then figure out how we could correct it. So the wrong way to do this is to just go, oh, cotangent on the unit circle, that's fine. Inverse reciprocal inside, I'm still fine. So we could write this as tan inverse of negative 3 over square root of 3. And you might have been clever enough to go, okay, what if I multiply the top and bottom by square root of 3? And get, that's actually asking for the tan inverse of negative 3 square root of 3 over 3, which is actually just negative square root of 3. Are we tracking? Are you okay? Did I skip kind of those middle steps?
Wait, why is it? But that's the wrong way you said, right?
Well, we're mostly doing it right. We're mostly doing it right. We're going to come up with the wrong answer. Okay, we're mostly doing it right, but we're going to come up with the wrong answer. Okay, it feels like I'm doing everything right. Now I go to my unit circle, and I'm like, you know what? Tan inverse exists in quadrants 1 and 4. And so you figure out where tangent equals negative square root of 3, and you're like, Mr. Pabian, I already know the trick. The trick is you want me to put it on 5 pi over 3, but I'm like, I can't get there for tan inverse, so I'm going to make this negative pi over 3. And you're like, okay, I covered all of the big mistakes I could have made. Mr. Pabian said most of us will get this wrong on the test. I did not, because I followed all the right steps, and I got negative pi over 3. You have the answer incorrect. That is incorrect because the original question was cotangent inverse. What quadrant was I just in?
4.
Does cotangent inverse exist in quadrant 4? No, it's quadrant 2. So we actually need to add pi to that answer. Not 2 pi, but pi. Which is a couple ways to do this. We can do the Fingy method. The Fingy method is, I'm in the wrong quadrant. How about I just drag it across? And my correct answer would be 2 pi over 3. Or we can go, let's pretend tan inverse exists in quadrant 2. Well, that would be negative square root of 3. That leads me back to 2 pi over 3. However this works, what you're actually doing is you're adding pi to this. And that would be 2 pi over 3 would be the correct answer. I don't like because people mess this up all the time when they're adding pi. They mess up that thing. Just take your little thingy and drag it across to the right quadrant. Yes? It's equal to adding 180. Absolutely. Yep. We're just doing a half turn. Because 2 pi would be a full turn, so we're doing a half turn.
And tangent exists in quadrant 2.
Tan inverse. Tangent does, but tan inverse does not.
Okay, and that's why you have to add.
And that's why you have to add, because officially we should have crossed out this quadrant, went down here, and had to shoot it up into that quadrant. I like to just pretend, if I'm doing cotangent inverse, I'm just going to cross out quadrants 3 and 4, and just look for if tan inverse existed there. That can lead me to my angle as well.
Okay. So you didn't have to find that by adding pi. You could have just known from the beginning it's either one.
Yep. So you could have, in the very beginning, that's my method. But I give you multiple methods because everyone has different ways of remembering stuff. But my method is cotangent inverse exists here. So let's just get rid of that quadrant. I don't care if I have to go through tangent. I'm going to go, I don't care tangent exists in 4. I'm going to pretend it exists in 2 because it helps me get to the right answer for cotangent inverse.
Okay.
Then you don't have to worry about adding pi or anything. The Fingy method works great too. Just going, I'm in the wrong quadrant. Whoop, I'm in the right quadrant. Is that clear? I'm glad you asked that question. Okay, awesome. Other questions?
So
Go.
cotangent does exist in 1 as well, though, right?
Cotangent does exist. So if it's inverse of cotangent or tangent, they both exist here. So if I asked you for the cotangent inverse of, say, square root of 3 over 3, you would end up being right at pi over 3. You wouldn't have to do anything weird.
Gotcha.
So that's why I said don't focus on this problem too much. It shows up like once on the test. Kind of like where you had to factor out that number. It showed up once on the test and a lot of people got it wrong. It's okay. Don't base your whole life on memorizing this one fact. If you understand everything, you're like, okay, I'm going to really focus on this because this is the one that's going to trip me up, then you have time to do this. If you don't know how cosecant and secant work, probably don't focus on this because it's just like one little problem. All right, other questions? Okay, then we're doing something new. New but not new. Will not be on the quiz. Will not be on the quiz. This is actually solving functions using sine and cosine. So solving trig expressions. Solving trig expressions. Can we make sure we pick up our head? And I'm actually going to focus on this, what's said here. It says find the exact solutions in the interval 0 to 2 pi. This is actually going to tell me that there's going to be multiple answers for the most part. That we're going to probably have multiple answers. I do want to focus on the part that all of this is accessible to everyone. So right now I have sine x minus square root of 2 equals negative sine x. Now this says, and my step says, isolate the trig expression. That means I need to get sine x all by itself. I need to get sine x all by itself. So real quick, let's just think about this a different way. Can you picture with me? This says y minus square root of 2 equals negative y. In fact, I'm going to write this off to the side. What I'm thinking here, I'm thinking y minus square root of 2 equals negative y. This should be something you guys can solve. How would I solve that? If I'm looking for this one. We're no longer on that one. I just have y minus square root of 2 equals negative y. I need to solve for y. We could add root 2 to both sides. We could get y's on the same side. We have lots of steps we could do. Let's move the y first. So how would I move this negative y to the other side? I would add it. If we're going the other way, we would subtract it. From this way, we would add it. So I'm kind of picturing in my head, well, that'd be adding y. That would give me 2y minus square root of 2 equals 0. What's next? Add root 2 to both sides. So we'd have 2y equals square root of 2. What's next? Divide by 2. You should be able to do that. If you don't, come see me, because that's the key to this one. Can you solve equations? Now, the only difference is instead of y, I have sine x. But we're doing all the exact same moves. I need to get sine x all by itself. So the first thing you're going to do is you're going to add sine x to both sides. Sine x plus sine x equals 2 sine x's. Minus square root of 2 equals 0. I'm still trying to get sine x all by itself, so that means I'm going to add 2 to both sides, and I'm going to divide by 2. So we're doing all the same steps. So I have plus square root of 2, plus square root of 2. That's going to give me 2 sine x equals square root of 2. Now I'm going to divide both sides by 2. Remember, this is linked together by multiplication. 2 times sine of x. The 2's would cancel out. I would then have sine x equals square root of 2 over 2. Now, in previous lessons, if I said solve for x, and that alone, we would take the sine inverse of both sides. We're not. We're supposed to find the exact solutions on the interval. The exact solutions on the interval of 0 to 2 pi. So we need to think about this just a little bit differently. Instead of taking a sine inverse of both sides, instead we're going to go to our unit circle. We're going to go to our unit circle. And what this graph is, what this equation is asking you for is figure out where sine equals square root of 2 over 2. Okay, Can anyone look at a unit circle and tell me where does sine equal square root of 2 over 2? Pi over 4, okay. And 3 pi over 4. At both those places, you should see that sine equals a positive square root of 2 over 2. That means those are your two answers, that we're going to have x equals pi over 4 and 3 pi over 4. So this is asking, what values can I plug in here that will make this statement true? I could plug in either one of those, and this statement would be true. Sine of pi over 4 equals square root of 2 over 2. Sine of 3 pi over 4 equals square root of 2 over 2. So we're giving multiple answers for these. So that is just straight up isolating our trig expression. My next one is taking a square root of each side. So rather than picturing this as being tangent x, think of this as just being like y squared. 3y squared minus 1 equals 0. Your first thing is to get all the numbers and everything to the other side. So the first thing I'm going to do is I'm going to move this 1 to the other side. And that will be by adding 1. So I'm going to add 1 to both sides. That will give me 3 tangent squared x equals a positive 1. Now I'm going to divide both sides by 3 to give me tangent squared x equals 1 over 3. Now don't forget about the fact that tangent squared x is the same thing as tangent x squared. How do I get rid of a square?
Square both sides.
I take the square root of both sides. This works for here as well. However, this leads us to something that a lot of us are going to forget about. We will have a square root on the bottom, but before we get there, I actually have to add something to this. I am the one that took the square root of both sides. When you are the one that took the square root of both sides, you are the one that took the square root, you need to add something in front of the square root you created. We need to include the plus or minus. So when you take the square root of both sides, you must include plus or minus. So to get this one 100% correct, you're going to have to say tangent x equals plus or minus the square root of 1 over 3. Depending on how good you are with square roots, we'll tell you how many steps you have to do next. Now remember, when you have a fraction with the square root of it, that square root goes to the top and to the bottom. So this is actually plus or minus the square root of 1 over the square root of 3. What's the square root of 1?
1.
So I really just have 1 over square root of 3. But that's a problem. We can't have a square root in the denominator. What do we do to get rid of a square root in the denominator? Multiply by that square root. So I'm just going to go ahead and say, well, if I multiply the bottom and top by square root of 3, I'm going to have plus or minus square root of 3 over 3. So this whole thing is looking, where is tangent equal to positive or negative square root of 3 over 3? Now, here's the interesting part about this. Tangent's always positive or negative. There's no third alternative. That means every quadrant must be accounted for this answer. So what I would do is I would look in quadrant 1 and see where tangent equals either a positive or a negative square root of 3 over 3. In quadrant 1, what angle is tangent equal to square root of 3 over 3? Pi over 6.
How do you know that?
You're going to look at your unit circle. So look at your unit circle, look at pi over 6. What's your tangent value there?
One outside of this.
Yep.
Oh, yeah, root 3.
Yep. Root 3 over 3. Now, because it's positive or negative, there must be 1 in every quadrant. What can help you here is if you know the first thing is pi over 6, you should know quadrant 2 is going to be 1 less. So if I have pi over 6, my second quadrant should be 5 pi over 6. Look at 5 pi over 6. At 5 pi over 6, is tangent either a positive or negative square root of 3 over 3? Should be negative there, right? In quadrant 3, Maybe I should write this on here. So we have 5 pi over 6. Our next one should be one more. So we should be able to look at 7 pi over 6. And don't take my word for it. You should be looking at unit circle. Is tangent equal to either a positive or negative square root of 3 over 3 at 7 pi over 6? Yeah. And then our last one should be 11 pi over 6. And now I'm going to focus a little bit more on this thing up here. Didn't focus it on too much last time, but now I'm going to focus on this. They said give me every answer between 0 and 2 pi. So no coterminal angles. I'm just giving all the answers between 0 and 2 pi. That works. Those are all my answers from 0 to 2 pi. Questions on taking the square root of both sides? Make sure you include your plus or minus. When you take the square root. If you're given a square root, don't put a plus or minus on it. Only if you took the square root of it. Oh, sorry. I'll leave that back up.
Can you go back up to the first?
I sure can. Questions, or you just got to finish writing something? Okay. All right, so the next thing we're going to talk about, and the thing that everyone loves, is factoring. Don't always make factoring the hardest possible question you can. And that is where, I don't know if you guys did factor by grouping, if you did like a star method, that X method or anything.
We did it every one. Factory's always.
But here's don't always jump to the hardest possible solution. And what I mean by that is, I'm going to put a little note up here. Note. Let's say I give you x squared plus x equals 0. People will immediately try to put that in a binomial and do all the different methods to solve it. I don't have 3 terms. If you don't have 3 terms, you shouldn't be doing factoring by grouping. You shouldn't be drawing your x's. You shouldn't be doing anything like that. You should look for factoring out something first. So my question is, on the left-hand side, I'm just looking, is there an x in all of the terms? Yeah. Pull out an x and see what happens. So I'm going to factor out an x and see what happens. So if I pull out an x out of both of those, remember, factoring out means divide. So if I pull out an x, it means divide. X squared divided by x would leave an x in its place. X divided by x would leave a 1 in its place. That leads me to 2 answers. Either x equals 0 or x plus 1 equals 0. So don't immediately look at, oh, it's squared, I can't do it. There's really easy ones out there like this one that just you have to factor something out. That's the first example. The first example says sine squared x equals 2 sine x. Now you might say, Mr. Papian, it's not all on the same side. You can put it all on the same side. It's called math. So we're going to go ahead, and the first thing I'm going to do is I'm going to move that 2 sine x to the other side. So the very first thing I'm going to do is I'm going to subtract 2 sine x. I'm also going to make sure you don't divide both sides by sine x. You lose an answer. You lose 50% of the problem if you use division here. All right. So now I have sine squared x minus 2 sine x equals 0. Now, this is the exact same thing that's up here. If this would be x squared minus 2x, we'd pull an x out front. Rather than pulling an x out front, I'm going to pull out the entire sine x. So we're going to pull an entire sine x out front. That's going to now give me sine x times, when I have sine x squared, or sine squared x, and I divide sine x out of it, I'm left with sine x. Minus 2 is correct. Hey guys, you need to keep it down. There's classes going on. Did you hear me? All right, that gives us 2 possibilities. And this is called the zero product property. Either this part equals 0, or this part equals 0. Because something times something, one of them has to be 0 for it to equal 0. Something in that chain has to equal 0 for the entire thing to equal 0. So that leads me to 2 questions. On your unit circle, does sine ever equal 0? It should, right? Where does it equal 0? And pi. Now here's the thing. I'll get some people that answer this. They'll go 2 pi. Well, the sine of 2 pi equals 0.
Yes.
Yes, it would. Why would I not include that in my answers? Because it's the same thing as 0, and more specifically, if you look up here, it says 0 to 2 pi. Do you notice the parenthesis after the 2 pi? That means do not include 2 pi. So that's why we do not include 2 pi. I'm going to cross that out, and I'll just highlight 0 and pi. Look up your head. Yeah.
So if we were to put 2 pi, would that just be wrong, or like?
It would be wrong. Yeah. I'm not going to take a whole bunch of points off or anything.
What do you get from sine of x times sine of x minus 2 equals 0 to sine of x equals 0?
So this is called the zero product property, that if I have something times something equals 0.
Yeah.
Either the first something, which is sine x, equals 0, or the second something equals 0.
Right.
It's kind of like if I just had a times b equals 0, either a equals 0 or b equals 0, or both of them. But one of them has to equal 0 for it, the whole thing to equal 0. So this sine x is just my a part. This is just my b part. Okay? Other questions on this one? We haven't finished it yet, though. All right, we do have to do the other thing. The other thing says, where does sine equal 2? Look at your unit circle. When does your sine equal 2? That should have stopped us because it never does. This does not exist. Sine can only, the highest point sine can be is 1. At pi over 2, sine equals 1. That is the highest point it could reach. So let me just erase this real quick. So if I look at my unit circle, sine equals 1 at pi over 2. It never gets up to 0, 2. It can't. That's not on my unit circle. That just does not exist. There is no number I can plug in for this x to make it equal 2. All right, so the factoring in this section shouldn't be overly complicated actual factoring. I usually have ones that we can just guess and check our way through. We just have to remember how to guess and check our way through it. So here's my example. We have 2 sine squared x minus sine x minus 1. I'm going to do something to make my life a little bit easier. I'm going to say, what if I just replace sine x with, I don't know, someone say a letter. G. I'm just going to let sine x be g. That's going to allow me to rewrite this as 2g squared, perfect, 2g squared minus g minus 1 equals 0. Now, I'm going to notice this is not like the last one, because I have that minus 1. I can't factor a g out of everything. So that means I need to turn into a binomial times a binomial. Good? I'm assuming it was important. Okay. All right, so we're going to have a binomial times a binomial. Now, I know the first things in both of these binomials need to multiply together to give me 2g squared, which means one of them needs to be a 2g. The other one needs to be a g, because 2g times g equals 2g squared. It's the only thing that can work. Now I know the last two things, this empty space and this empty space, has to equal a -1. Well, to be a -1, I have to have a 1 times a 1 first. I have 1 times 1, which would equal 1, but it has to be a -1. So I kind of have the first numbers. I kind of have the last numbers. Now, how we're going to get whether these are positive or negatives, we got this negative g we have to create. So to create that negative g, we have to realize that we are doing 1 times this and that times that, and we're adding them together. So right now I have 2g times 1, which would be 2g, plus 1g, which would equal 3g. That's not going to work, so they both can't be positive. One of them has to be a negative. So let's just try one. Let's try making this positive and this one negative and see how that works out. Well, 2g times -1 is a negative 2g, plus 1g equals a negative. That works. That's what I'm saying. The ones I'll pick for this will be guess and check ones that you don't have to go through all of the rigmarole. That it should be easy enough that you can guess and check your way through it. So this is correct now. Now we're going to go ahead and use our zero product property to say, oh, this is 2g plus 1 equals 0. This second one is g minus 1 equals 0. If I was going to solve for g on this one, I'd first subtract 1, and then I would divide by 2. So that first one I'll put ... because you might have to do a little bit more work than that, but we should come up with a -1/2. And for this one, we should come up with g equals 1. But we can't be done because I just substituted g and I have to put the original thing back in. I said sine of x is in place of g, so we're going to go ahead and take that sine of x and plug it in for those g's. So I'll take that sine of x, I'll plug it in for that g, I'll plug it in for that g. I'm actually going to go over to the other side real quick. So that gives us two possibilities. Either sine x equals a -1/2, or sine x equals 1. Does sine ever equal a -1/2? How do I know what quadrants to look in? Where's sine negative? 3 and 4, because 1 and 2 it's positive, so 3 and 4. So if you give me angles for this, can someone raise your hand and tell me where there's one place? 7 pi over 6. That must work because we are in that quadrant. And our other one should be what, 11 pi over 6? Okay. Is sine ever equal to 1? Yes. It's just not, it can never be bigger than 1. This should happen at pi over 2. Now, I will premise this with, you don't have to pick a variable. It's easier for writing purposes, so you're not writing sine x a whole bunch of times. It's just a little easier to turn your sine x into a variable, or your cosine x or whatever. There's nothing that says you have to do that. If you want to write this fully out with sine of x's all the way through because you mess up, that's fine. This is just an alternative to make your life a little easier writing it out. Questions on anything we just covered? All right, then the rest of the time is yours to work and ask questions. Remember, we do have a quiz